Out. Why? Do you not want to be recorded? You sure?
Yeah.
Why don't you switch with somebody so they can answer my questions?
You got it.
No.
All right, come back here, Jan. Let's go. Just come back here. I'll walk you through it. All right, so midterm review, macro review number 5. We are looking at bonding. Please don't make me talk over you. So, explain the difference between ionic and covalent bonding. What's an ionic bond?
Metal and non-metal.
Okay, there's a lot of different ways to look at it. So, ionic. Jan's absolutely right. We have a metal and non-metal. What about for covalent?
2 non-metals.
Covalent, 2 non-metals. Perfect. All right, what other ways can we look at ionic versus covalent? Cation, anion. And obviously with covalence, we are not looking at ions at all. All right? So, what's another way?
No ions.
Yeah, we just said that for covalent. What about the bonds themselves? The bonds themselves. What's ionic? What are we doing with the electrons? What are we doing with the electrons? We are transferring electrons. What about with covalent? Sharing electrons. Yeah, sweet. There's number 1. Number 2. Describe how compounds containing a polyatomic ion contain both ionic and covalent bonds. Ooh, we haven't talked about this one yet. Yeah?
Is it because there is one metal and 2 non-metals? One of the metal and one non-metal will make an ionic, and the 2 non-metals make covalent?
Maybe. Take NO3 for example. So, number 2. Take NO3 for example. Nitrate. For nitrogen and 3 oxygen, we have all nonmetals. Everybody agree? Mm-hmm. So technically, the nitrogen is covalently bonded to the 3 oxygen. So within this polyatomic ion, we have all covalent bonds. But when we utilize nitrate, what do we combine it with? What type of compounds have we been forming when we use polyatomic ions? Ionic, right? They're ions, so they actually form ionic compounds. So let's take another polyatomic ion, for example, NH4 plus. Again, all nonmetals, therefore the N is covalently bonded to 4 hydrogen. But if we put the 2 together, NH4, NO3, how are those 2 polyatomic ions bound? With a cation and an anion. What's that the definition of? An ionic bond. So, within ammonium nitrate, NH4NO3, we have quite a few covalent bonds as well as an ionic bond. So with polyatomic ions, we can have both covalent and ionic bonding. That is what number 2 is getting at. Questions about that? Jan?
No questions.
No questions?
Wait,
Well, then ask your question.
can we do all that over again? Because I'm still confused.
All polyatomic ions are covalently bonded. NO3 contains covalent bonds between nitrogen and oxygen. NH4 plus the N is covalently bonded to the 4 hydrogen. So within polyatomic ions, we have covalent bonds. They're nonmetals covalently bonded together. When you combine polyatomic ions with other ions, they are going to form ionic bonds. So even though our covalently bonded polyatomic ions exist within our compound, because we're putting a cation with an anion, we have an overall ionic compound. So when you have a polyatomic ion, you can have both covalent and ionic bonds. All right, number 3. Describe the bonding that will exist between calcium and chlorine. What type of bond? Why ionic?
Because it's a metal and a non-metal.
Metal and nonmetal. So number 3, we have an ionic bond. What's the compound that's formed? Ca plus 2, reference it. Cl minus 1, reference it. So what compound is formed? CaCl2. You need to get to the point where you're not having to draw all of this out to get to your formula. You should be able to reference Ca on the periodic table as having a plus 2 oxidation state, Cl as having a minus 1, and reason out pretty quickly that you need 2 chlorides for every 1 calcium, CaCl2. All right, what about number 4? Explain why copper can form 2 different compounds with chlorine. It's a what? Jan, it's a what?
Transition metal.
Transition metal. So, in this case, we know that it forms multiple oxidation states. So copper can be plus 1, copper can be plus 2. If it's forming a compound with chlorine, copper plus 1 would be CuCl, and copper plus 2 would be CuCl2. Copper 1 chloride, copper 2 chloride. Copper 1 chloride and copper 2 chloride. Again, what are your Roman numerals in there to tell you?
Oxidation state.
Oxidation state of your metal. It is not how many coppers you have. That's a common misconception for some reason. All right, that's number 4. How is an empirical formula different from a molecular formula? So we haven't really gotten to molecular formulas yet. I was going to put a test question on there, but I decided not to. So you will have one test question over empirical formulas and calculating empirical formula. I'm not going to put anything on there for molecular formulas. So, empirical formulas, remember we're starting out from a percentage and working our way to an actual formula. You guys recall? So, for example, you have 11% hydrogen. You have 89% oxygen. What would be the empirical formula?
11 grams.
Well, we assume that it's out of 100 grams, so 11% is what?
11.
11 grams of hydrogen. And how many grams of oxygen?
89.
Oops, 89 grams of oxygen. First step, convert both to what? Moles. So, divide by the molar mass. 1.01 for hydrogen, grams per mole. And, somebody calculate that. And 16.00 grams per 1 mole for oxygen. What's 11 divided by 1.01?
Like about
10.9? And what's 89 divided by 16? 5.56 moles. We take our lowest mole amount and we create a ratio So divide each by 5.56. You get 1 oxygen. And divide by 5.56, you get about 2 hydrogen, giving you an empirical formula of H2O. So, you guys will have a problem that looks very similar to that on your test.
Portal, will this video be on your
It tastes like Hollywood.
Huh, I don't know where the video went.
No.
please tell me it's gonna be there.
I'll have videos for all these up eventually as this computer decides to work.
I have a question.
Yeah, go ahead.
Okay, since our midterms is like next week, will our bonding quiz also be next week, or would it be like after the break or like something?
Bonding quiz.
Like,
Bonding
don't we have
quiz.
to have a test over?
It's built in.
It's built in the midterm.
Oh, okay. So will we have to complete all the homeworks for bonding and like the midterm?
Yeah, all your bonding homework is due on test day.
Which is Monday.
Guys, what's your midterm exams?
Sunday?
We're just gonna do like everything like this weekend. I wonder what's his name? Martin? Coach Martin, if he's gonna make us do another test.
Wow, what is going on with this?
Exactly. What if he makes us do it? Wait, what? How do I make sense? Yeah, okay, cool. Okay. I'll just read it then. I'm not gonna do anything. Watch him be like, oh no, where's your reading guide? I'm like,